Continuing with what we are looking at here of determining the modulus and argument. So our next example here is this is b. Okay, this is 1 minus 1 j. So a simple plot is this reveals. So when we see from the plot here, we see that the angle, the modulus, the principal argument here, the angle between the positive x, the angle between negative pi, okay, and pi, and which is from the positive x-axis here, we see that it's going to be this angle theta here. So we know that that theta here is simply now the tan inverse. The distance here is 1, and this is 1. That is 1 over 1. But since it is below the x-axis here, we shall put the negative there. And then when we come to this one here, it is clear that the principal argument here, the angle between negative pi and measured from the positive x-axis, okay, is this one here, is that theta. However, that is we can get that as just getting the whole of this pi, then we subtract this angle here. Maybe let's say alpha pi. If this is alpha, pi minus alpha, which is pi minus, and then the alpha is simply tan inverse over 1, okay, over 1. Okay, where is that? Yes, it's this one here. But we know tan inverse of 1 is simply 1/4 of pi, then we have pi minus that, which gives you 3/4 pi. Then lastly here, if we plot this one here, negatives root 6 and negative root 2. Okay, so if it lies in this quadrant here, so we know that our angle theta, we cannot take this one here to be our angle theta because it lies out of this range. Therefore, our theta, our principal argument, is going to be this angle here, okay, from the positive x-axis to this, to our to the line here, okay. However, what we have to know is that now, if we are using this, now this is negative, okay, because if we are measuring angles in that direction, it's going to be negative. So again, as usual, now this is going to be, we can say that it is going to be the negative of pi, because we shall measure up to here, this is pi, then we can subtract this angle here. And if this one is maybe gamma, so we know that gamma is simply going to be tan inverse of that distance here, which is root 2 over root 6, okay. So you can check what they have here, then tan inverse, okay, tan inverse of that, and then you have the negative, and then you can verify what we are given is there. So a few examples here. They also have some Matlab commands which you can simply use, and then you can play out. Like I said, it's always good to just play out with this one here. So they say that in Matlab we can just write z is equals to 4 plus 3i. That is how we can write. So let me see. I will clear that. We shall say that z is equals to z equals to 4 plus 3i. We have 4 plus 3i. Oh yeah, okay, that's it. Then they say z bar. No, z bar. Did I mean bar? How do you find the conjugate? Let me see. Okay, so what do they say? Sorry, z bar is simply what they were using. Sorry about that. Z bar. Then if you want to find the conjugate, the complex conjugate, then you have the conjugate of z, and then they have it as that, okay. So you can try out the other commands which are given to us. Maybe what else? Yeah, it's just try and copy and paste, and then you see or they give Matlab here, or if you want also to use Maple, whichever you're using here. So they give a series of things here. We can put in these z's, and then you can add them, and then you can see the result. You can divide them, and then you see the result here. Okay, sometimes if you want, they say if you want exact arithmetic, if you don't want those rounding offs, so you can use the symbolic toolbox. You're simply going to create Z1, Z2 and Z4 as these symbols to represent these these different complex numbers, and then Z4 is Z1 divided by Z1 divided by Z2, and then you can do the rest. Maybe you can try that. So I'll just I can't copy and paste for here. So here let me see, I have we shall say Z1 equals 4 plus 3i, 4 plus 3i, 4 plus 3i, and then what is Z2? Z2 is 3 plus 2i. Z2 is 3 plus 2i, and then this, did they say Z2, and then what else? Z1, Z2, oh, Z4. Okay, I was wondering where is Z3, but it's okay. We can say Z3 Z3 or Z4 is Z1 divided by Z2, and then we do that. Okay. Okay, let's see what Z4 is. You can also do it by hand and then see what it gives. So that is the answer for Z4. And then okay, wait a minute, why don't I have the exact? Okay, I should have first created this symbolic, this is Z1. Do I have commas in there? No, I don't. Z1 space Z2 and Z4. I create that, then I can do that again and say Z1 is that, Z2 is that, and then I'll say Z4 is that, and then I can see, oh, it's the same. Okay, Z1, Z2. Okay, let me do this and maybe clear everything and start out again. Okay, so I say that, then I say Z1 is that, then Z2, and then Z4. Okay, let me see, double Z4. Okay, it returns Z4 is Z1 over Z2. I'm not so sure why it doesn't return it in the form here, which is negative 6 over 13 minus 17 over 13. Okay, because it is returning it in the form of double here, writing these digits here in form of these decimals here. So I'm not so sure. Anyway, I'll check that out later. Now we can maybe move on, and then we see Z4. Did it work? I am not so sure why. Okay, this should have been the same as how it is written here, as in negative 6 over 13 minus that. Okay, I'll check that out later. Let's just move on here for the purposes of time. The real and imaginary parts okay, yeah, you can't just write out those commands because they say you can say that they're real, but then you put in z4 and then it gives you that. And then what is the command for the imaginary? emag, okay, and then you can say emag z4 and then it gives you that. Okay, you can just try out that, just do a copy and paste and just run. That is the best way to learn. Then whatever is here, plotting them, you can also plot them on the anger diagram, you can label them, you can have a set of points and do many things. Okay, so it is just a copy and paste. Okay, you can read through that. Okay, this is quite nice. When you're relaxing, you just do copy and paste and run through and see whatever it gives you. Okay, and a few exercises here. I am sure you should be able to go through all these exercises here. It shouldn't be that hard. Okay, so in the next section we shall talk about the polar form. So bye for now and see you in the next section.